Let's start the next chapter. Chapter 10 is called Tropical Influence on the Extratropics, a Zonally Averaged Perspective. Essentially, we'll look at the Hadley cell. So we have been looking at equatorial waves and their trapping, and we didn't explicitly talk about tropical influence, but we talked about the strong and weak trapping and the extent of the trapping latitudes based on basic states, etc. And then we looked at extratropical influences on the tropics, also based on basic states, focused basically on the western ducks and the tropical upper tropospheric trough, which led us to this kind of a figure at 200 hectopascal geopotential height on the 345 Kelvin isentropic surface. We looked at the intrusion of the isentropic potential vorticities from both hemispheres into the deep tropics, and we saw that they are correlated with the vertical motion and OLR as an indication of the convective activity. So knowing all these zonal asymmetries, especially when we look at the Hadley cell, why should we do zonally symmetric solution, zonally averaged picture? There are eddies in the longitudinal direction, there are orographies, interactions with the flow producing eddies, there are heating distributions and so on. Nonetheless, the zonal mean picture does provide lots of insights, which we will take a look at in this chapter. So you remember the zonal mean meridional picture of the zonal and meridional winds for JJA, DJF, MAM, and SON. Of course, you remember that the winter hemisphere here in the southern hemisphere has a strong vertical shear with the westerly jet that goes unstable, and the shift of the ITCZ can be seen again as the northern hemisphere winter jet. The summer jet becomes weaker, shifts poleward, and this corresponds to the Hadley circulation. So then the Hadley circulation, as you remember, is related to the diabatic heating in the deep tropics, rising motions, divergence at the top, convergence at the bottom, and the question of where the Hadley cell terminates is not so simple. And in this chapter, Peter doesn't explicitly talk about it at all. He assumes that the baroclinic instability and the eddy fluxes determine the influence of the tropics on the extratropics, without saying very much about the termination of the Hadley cell. So at the end, I just added one little figure to raise those issues. We'll come back to that. The climatological winds, if we look at the zonal winds and wind speeds for January and July on 370 Kelvin isentrope, again gives a slightly different picture than the pressure coordinate, which we will see in a minute, but the basic ideas remain the same. You have easterlies on either side with a westerly duct in the eastern Pacific, which corresponds to the termination or the exit of this Asian jet coming off of Japan and China here. We will see later on that this has kind of an stationary eddy and transient eddy kind of structure, and there is the other piece of the North American jet coming off of land over here, but here is the westerly duct that we talked about in terms of signals propagating from the northwest to the southeast and southeast to the northwest. For the summer months, we ended up with this tropical upper tropospheric trough that also was critical for extratropical influences to propagate into the tropics and potentially generate convective activity and produce baroclinic processes, upper level, lower level coupling at 10 to the 6 meter spatial scale, which Charney was struggling with. On the pressure coordinate, we have the 200 hectopascal wind field. Again, you see the slightly different picture, but you still see the trough and the westerly duct. You don't clearly see the exit region of the jet and the separation of the Asian and North American jet as clearly as we saw on the isentropic surface, but nonetheless the seasonality is very clear here. So ignoring all these zonal asymmetries, we're going to average and look at the zonally symmetric meridional circulation to understand the tropical influence on the extratropics. This is just the potential temperatures we had talked about. Again, characteristic feature of increasing upward as you go away from the equator, and there is this increasing with height, and there are the seasonal changes. When you look at the equivalent potential temperature, you get reversal of gradients, which is obviously corresponding to the conditional instabilities that are related to the convective activities and the reduction of the static stability by the convection, etc., that we talked about before. This is just another way of looking at it that we did in the last chapter. The meridional section, again looking at this along the northwest southeast section XY, going from 60 west 45 south to 45 north, 160 east, showing the westerly jet in the northern hemisphere and the southern hemisphere, the easterly dome, and the potential vorticities, potential vorticities in this section that we had studied again for intrusion of extratropical signals into the tropics. So we'll talk about the Hadley cell and what the previous theories have been saying, and surprisingly several centuries after Halley and even Galileo and Copernicus talked about this circulation, we are still not completely agreed upon in terms of the processes that determine the termination of the Hadley cell. So we'll see briefly what those issues are. Okay, so this is a very short chapter, but very important chapter before we go on to the full 3D physics, where we open up the zonal average and look at the zonal distribution of heating and how that affects the tropical extratropical connections. Okay.